Hey everybody, welcome back to chemistry. If I can increase the slide. It says select the compound that has angles nearest to 120 degrees, and there you have 5 choices. So you'll have to pick the choice where the angles around the peripheral atoms of the molecule are about 120 degrees. So if I can lower the slide. Okay, so the way you solve this problem is you have to solve it in some steps. And so one of the things I want you to notice of those 5 formulas there, some of them are molecular formulas. And a few of them look like Lewis structures, but they're actually incomplete Lewis structures in that they don't show you lone pairs and they don't show you single bonds. And then I think there's one structure there that is a complete Lewis structure. So you have to figure out, of those 5 molecules, which one has the peripheral atoms that are about 120 degrees from each other. So for each of the molecules, you'll have to carry out a bunch of steps. And so the first step is you'll have to write a correct Lewis structure for the molecule, which includes all lone pairs in the molecule. The next thing you're going to have to figure out is the number of electron groups around the central atom. Then you're going to have to figure out the electron geometry of the molecule. And then once you figure that out, you can figure out the angles between the peripheral atoms in that molecule. So let's go ahead and start with the first one. So this molecule, we have oxygen, double bonded to carbon, double bonded to sulfur. So this is a little tricky because they gave you an incomplete Lewis structure. And so we have to figure out the correct Lewis structure for this. And so let me kind of walk you through that. So oxygen has 6 valence electrons, carbon has 4 valence electrons, and sulfur has 6 valence electrons. And so it looks like we have a total of 16 valence electrons, or 8 pairs. So let me just start from scratch and figure out the Lewis structure here. Okay, so what we have here is we have oxygen on one side, carbon in the middle, sulfur on the other side. Now, we have 8 pairs, and so what I'm going to do is I'm going to bond atoms together with a pair. So here is one pair, here is another pair. So we have 6 pairs to go. So I will put them on the peripheral atoms first. So 3, 4, 5, 6, 7, 8. Okay. So one thing you can sort of see right now is that while the outside atoms have octets, the carbon does not. And so to remedy this situation, you're going to have to move this lone pair off sulfur, and it'll become a bond between carbon and sulfur. But you have to do a little bit more than that. You see this lone pair on oxygen? You're going to have to move that here to be a bond between carbon and oxygen. So let me rewrite the molecule. So this is a correct Lewis structure of the molecule. So let me just erase that. Okay, so that's step 1. Step 2 is we have to figure out how many electron groups the central atom has. And so let me remind you something. The number of electron groups is equal to the number of bonding groups plus number of lone pairs. Okay, so again, we're trying to figure out the number of electron groups for the central atom. And so you can see first off that this central atom has no lone pairs, so we have 0 lone pairs. Bonding groups. One of the things you have to remember is if you see a single bond, that is considered one bonding group. If you see a double bond, that is considered one bonding group. If you see a triple bond, that is considered one bonding group. So what you see here is that we have 2 bonding groups. So you can see the number of electron groups that carbon has. It really only has 2. So you just figured out the number of electron groups, and so it's 2, and I'm hoping that you know that when you have a central atom with 2 electron groups, those groups will get on the opposite sides of the central atom, and so the molecule will appear linear. Okay, so at this point, you should be able to figure out what the bond angle is between the peripheral atoms. And so, again, because the central atom has 2 bonding groups, the oxygen and the sulfur are opposite of one another. So here, I think you can sort of see that this angle here is 180 degrees. So this is not the correct answer. Okay, so let's move on to the next one. So here for the next one, they are giving you a molecular formula, CHI3. And again, to figure out what the angles are between the peripheral atoms in this molecule, you first have to draw a correct Lewis structure, figure out how many electron groups the central atom has. That tells you electron geometry, and therefore you can get the bond angles. So here we go. So carbon has 4 valence electrons. Hydrogen has 1 valence electron. And iodine has 7 valence electrons. But there are 3 iodines here, so that's going to be 21 valence electrons. And so it looks like we have 21 plus 1 is 22, 22 plus 4 is 26 electrons, so 26 electrons. So we have 13 pairs. All right, so let's go ahead and try to draw a Lewis structure. So we have carbon as the central atom, hydrogen is always on the outside. Iodines are also outside because they're a little more electronegative than carbon. Okay, and so now let's go ahead and draw in bonds. So this is 1 pair of electron, the second, third, fourth. Now, you know that you can't add any lone pairs around hydrogen, but you can stick them around the iodine. So 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is a correct Lewis structure. Now, you have to figure out the number of electron groups this carbon has. And so I think what you can see is the carbon doesn't have any lone pairs. It does have 4 single bonds. Each single bond is a bonding group. So it looks like carbon has a total of 4 electron groups. So I'm just going to note that here. This is 4 electron groups. That tells you what the geometry is. The geometry is tetrahedral. Now you can figure out what the angles are going to be between the iodine atoms and also between the hydrogen and the iodine. So the bond angle between the iodine atoms is going to be a little different than the bond angle between hydrogen and iodine, but they're going to be pretty similar. And so you sort of have to figure out what the bond angles are. And let me just remind you of something. So this has a certain 3-dimensional structure. Again, it's called tetrahedral, where you have a central carbon atom. And so I'm going to try to draw it here. We have a hydrogen going to the top here, maybe an iodine going to the side. And then I have another iodine, which is heading out toward me. And then we have a final iodine going into the board. And so one of the things I'm hoping you remember is that in a tetrahedral structure, the angles between the peripheral atoms here are not 90 degrees. They are 109.5. So this is 109.5 degrees. So here, this is not the correct answer because this is not 120 degrees. Okay, so we'll move on. Okay, we're going to skip the next one. Let me just quickly draw out the Lewis structure of CH4. I'm hoping you can figure this out on your own, but it will look like this. Carbon, hydrogen, hydrogen, another hydrogen, and another hydrogen. This is correct for CH4. Now you can figure out the number of electron groups the central atom has. I'm hoping that you can see that this carbon has no lone pairs. It has 4 single bonds, therefore it has 4 bonding groups, and therefore it has a total of 4 electron groups. So 4 electron groups. And so this is tetrahedral. And we already talked about what the angles are going to be approximately between the peripheral atoms in a tetrahedral molecule. So they're going to be approximately 109.5. So this is not the correct one. Okay, so we move on to the next one. And so here we have a molecule called ethine. It's also called acetylene. That last molecule, which I'm going to draw here, is a correct Lewis structure. So in this correct Lewis structure for this molecule, you'll know that the carbon doesn't have any lone pairs, yet the carbons have octets. So this is a perfectly good Lewis structure. So Let's just consider the number of electron groups around the left carbon here, and then just keep in mind that whatever we say for the left carbon applies to the right carbon. And so what I'm hoping you can see here is this carbon here has no lone pairs. It has two bonding groups, right? There's a single bond, which is one bonding group. There's a triple bond, which is another bonding group. So it has a total of two bonding groups. So that tells you that the number of electron groups for this carbon is 2. And that would be the same thing for this other carbon. And so both of these carbons have a linear electron geometry. And so here the angle between the bond going to the hydrogen and the triple bond going to carbon here would be 180 degrees. And same thing with this other bond here would be 180 degrees. And so this is not the answer, okay? So let's do the last one that I didn't go over. And so it's H2CO. So here's the problem. H2C with a double bond O, this is not a correct Lewis structure. And the reason is it's missing single bonds and lone pairs. And so let's go ahead and draw out a correct Lewis structure for this. So we have carbon, which has 4 valence electrons. And then we have hydrogen, which has 1 valence electron, but there are 2 here for a total of 2 valence electrons. And then you have oxygen here, which has 6 valence electrons. So we have 8 electrons here total, plus 4 gives you a total of 12 electrons. So there are going to be 6 pairs that we have to deal with, okay? So let me change the pen here really quick. Okay, so let me draw a Lewis structure. So we have carbon in the center, oxygen on one end, hydrogens on the other end, like this. First, let's bond the atoms together with pairs. 1, 2, 3. These hydrogens cannot accept pairs, so they go to oxygen. 4, 5, 6. So one thing you can see is that although this oxygen has an octet, the carbon does not, and so we remedy that by moving this lone pair from oxygen to the bond between carbon and oxygen. So it looks like this. Okay, this is a correct Lewis structure for H2C double bond O. And now what we can do is figure out how many electron groups that the central atom has. And so carbon is the central atom. It has no lone pairs. Each of these single bonds counts as a bonding group, and the double bond also counts as a bonding group. So we have 3 bonding groups plus 0 lone pairs. So there are 3 electron groups here, okay? So if that's the case, then the geometry of the molecule is trigonal planar. So in 3-dimensional space, the molecule really kind of looks like this. So I'm going to draw a plane here like this. And then what I'm going to do is I'm going to make sure all the 4 atoms that I'm drawing into this plane here are all in the same plane. So we have carbon here, and then maybe we have oxygen going off in this direction. And then we have 2 other electron groups. They're going to get as far away from this electron group going to oxygen as possible. So it's going to be about this angle here and about this angle here. So now I think you can see what the angles are going to be between the peripheral atoms. So this angle is going to be approximately 120 degrees. And same with all the other angles. So this is the correct answer. This is the molecule where the bond angles are near 120 degrees. So thank you for listening to that. We'll see you next time.